In the heart of a bustling city, a scientist named Alex stands in front of his lab. The morning light filters through the glass walls, casting colorful shadows on the shelves filled with vials and complex machines. Alex is engrossed in something, his fingers typing away at a keyboard. Suddenly, he pauses and looks up as if remembering an important thought. Alex explains, imagine you have two coins, flipped separately but always landing heads or tails together no matter how far apart they are. That's the concept of quantum entanglement. It sounds impossible, doesn't it? But this is what baffles scientists around the world. He continues, the story begins in 1935 when Albert Einstein and his colleagues proposed a test to challenge their own theories about quantum mechanics. They believed that something was wrong with these strange new ideas, they were too random, too unpredictable. So, they came up with an experiment: could particles be connected across vast distances? It seemed like a trick question at first, but over the years, experiments have shown it's not just possible, it's true. Alex then steps to one of his experimental setups. A large screen displays complex diagrams and equations dancing across its surface. Quantum entanglement is like this, he says, pointing to an equation on the screen. It defies our everyday understanding of how things work. In classical physics, if you change something here, it doesn't instantly affect what's happening over there. He walks closer to a small glass container filled with glowing particles. But quantum mechanics suggests that these particles are connected in such a way that any change made to one immediately affects the other, no matter how far apart they may be, Alex explains, his voice tinged with excitement. This isn't just some abstract idea anymore, it's something we can measure and observe. Experiments like those conducted by physicists Alan Aspect, John Clauser, and others have shown that quantum entanglement is real. Particles can. In the heart of a bustling city, under the glow of countless streetlights, lies an intriguing mystery that has puzzled some of humanity's brightest minds. It's a story woven from threads as fine as a spider's web, but with consequences far-reaching enough to shake the very foundations of our understanding of reality. Quantum entanglement is one such enigma. Imagine two distant stars that somehow remain connected, sharing their secrets no matter how vast the distance between them might be. It's like whispering across space and time, defying all logic we've known since Newton first formulated his laws of motion. The idea was first proposed by Albert Einstein in 1935 with a twist of skepticism. He famously called it spooky action at a distance. This phenomenon challenges the very fabric of our classical physics framework. How could particles separated by millions of miles communicate their states instantly? It's as if they share an invisible thread, binding them together no matter how far apart they are. The concept was more than just a theoretical puzzle, it began to take shape through experiments that pushed science into uncharted territories. One such experiment involved entangled photons, tiny particles of light, which revealed the startling fact that their states could be correlated even when separated by large distances. This meant if you changed one photon state, its partner would instantly change as well, no matter how far apart they were. This discovery sent shockwaves through the scientific community. It was a challenge to our understanding of locality and causality. It suggested that something faster than light might be at play, or perhaps reality itself is fundamentally different from what we perceive in everyday life. As scientists delved deeper into this phenomenon, they uncovered more layers of complexity. Entanglement isn't just limited to photons but extends across a wide range of particles, electrons, neutrons, and even larger molecules. Each new discovery brought with it a fresh layer of questions that seemed impossible to answer within the confines of classical physics. In the vast expanse of our universe, there exists a phenomenon so strange that it challenges everything we thought we knew about reality. This is the story of quantum entanglement, a concept so bizarre yet fundamental to modern physics that it has left scientists both perplexed and captivated. Quantum mechanics is often described as the science of the very small, dealing with particles at an atomic or subatomic level. But within this realm lies a peculiar phenomenon known as quantum entanglement. Imagine two particles being connected in such a way that whatever happens to one particle instantaneously affects its partner, no matter how far apart they are. This is not just a metaphorical connection, it's a real, tangible bond between these tiny entities. Scientists have known about this curious link for over a century now. It was first proposed by Albert Einstein himself in 1935, who famously referred to it as a spooky action at a distance. But even today, the very idea of such instantaneous communication defies our classical understanding of how things should behave. In fact, many early physicists dismissed quantum entanglement out of hand because it seemed too strange and counterintuitive. However, experiments over the years have provided strong evidence that this phenomenon is real. One notable experiment was performed by physicist Alain Aspect in 1982 at the University of Paris. He used a setup where pairs of photons, particles of light, were created together but then separated into two different directions. Despite being far apart, these photons still behaved as if they shared an unbreakable connection. The implications are staggering. If true, this means that information is transmitted between particles faster than the speed of light, which should be impossible according to our current understanding of physics. This has led many scientists to ponder whether quantum entanglement might even allow for some form of non-local communication or teleportation, a notion that was once considered science fiction but now appears within reach. But why does this matter? Why is it important beyond in the heart of a scientific revolution that challenges our very understanding of reality lies an enigma known as quantum entanglement. Imagine two particles separated by vast distances acting in perfect unison. One particle's state instantly influences the others, no matter how far apart they are. It defies all classical logic and physics we've grown accustomed to. Imagine, if you will, a pair of socks tied together at their toes. No matter where you separate them, on opposite sides of your house or even on different continents, the moment one sock is pulled, the other responds in perfect harmony. This is what physicists call entanglement, but instead of socks, we're talking about subatomic particles. The concept was first proposed by Albert Einstein and his colleagues Boris Podolsky and Nathan Rosen back in 1935. They called it spooky action at a distance. And their skepticism was well-founded. Quantum mechanics had just been born, challenging the very fabric of classical physics with its bizarre predictions and behaviors. Einstein himself, often referred to as the father of relativity, struggled with this idea. He famously stated that quantum entanglement implied action at a distance which he could not accept. To him, it was more than just an uncomfortable notion, it was a threat to his entire worldview. He proposed what is now known as the EPR paradox, suggesting there must be some hidden variables or local interactions we had yet to discover that would explain these phenomena. Years passed and experiments began to chip away at Einstein's skepticism, each one more convincing than the last. Experiments in quantum mechanics showed that particles could indeed influence each other regardless of distance, a phenomenon that seemed too perfect, almost as if there was some unseen hand guiding them from afar. One of the most famous experiments is the Bell test, named after physicist John Stuart Bell, who formulated inequalities that could be used to determine whether local hidden variables were possible. In 1964, he published The Enigmatic World of Quantum Entanglement continues to baffle scientists while intriguing the general public. It's a phenomenon so strange that Albert Einstein once famously called it spooky action at a distance. Yet this spooky action has real-world implications that extend far beyond the realms of theoretical physics. Imagine two particles, let's call them Alice and Bob. In classical physics, if you change something about one particle, the other should remain unaffected unless they communicate with each other somehow. But in quantum mechanics, when these entangled particles are separated by vast distances, a change to one instantly affects the state of the other, regardless of how far apart they might be. This phenomenon has profound implications for technology and our understanding of reality. One of the most exciting areas where this plays out is cryptography. Quantum entanglement can form the basis of secure communication systems that are virtually unbreakable. In a quantum key distribution system, if any eavesdropper tries to intercept or alter the data being transmitted through an entangled pair of particles, it will immediately reveal their presence. The security relies on the fact that measuring one particle affects the other instantly, no matter how far apart they might be. But beyond secure communication, there's also the potential for ultra-precise sensors and navigation systems. Quantum entanglement could revolutionize GPS technology by providing a level of precision currently unattainable with classical methods. Imagine ships and aircraft equipped with quantum sensors that can pinpoint their location to within millimeters, no matter how far they travel or what kind of terrain they encounter. In medicine, the implications are equally fascinating. Quantum entanglement could enable ultra-precise medical imaging techniques that allow doctors to see inside a patient's body in unprecedented detail, without invasive procedures. By harnessing quantum effects, future diagnostic tools might offer real-time visualizations at molecular scales, leading to more accurate diagnoses and personalized treatments. The potential for energy storage is another area where entanglement could play a significant role. As we peel back the layers of quantum entanglement, a phenomenon so strange yet fundamental to our understanding of reality, questions linger. How can particles be connected over vast distances without any known mechanism? It's as if they share a secret language that transcends space and time. Quantum entanglement challenges us to reconsider what it means for two things to interact, even when separated by light years. In the realm where classical physics fails, quantum mechanics reveals an interconnected universe that is both bewildering and beautiful. The more we explore these phenomena, the more questions arise. What does this tell us about the nature of existence? Are there deeper layers of reality waiting to be uncovered? The mystery deepens when we consider practical applications. Quantum cryptography promises unbreakable codes by exploiting entanglement's inherent security. Quantum teleportation could one day allow information to travel instantaneously across vast distances, a concept that boggles the mind yet holds tantalizing possibilities. Yet, despite its promise and intrigue, quantum entanglement remains elusive. The complexity of measuring and controlling these systems presents significant challenges. Scientists are working tirelessly to develop technologies that can harness this power while maintaining stability, a delicate dance between theory and practice. Perhaps most intriguing is the question, why does nature operate in such a mysterious yet precise way? Is there an underlying order, or do we simply lack the tools to fully comprehend it? As we continue our journey through quantum mechanics, one thing becomes clear. The universe is not as simple as we once thought. It's a complex tapestry woven with threads of both logic and mystery. Each discovery brings us closer to unraveling its secrets but also reveals new enigmas waiting to be solved. Quantum entanglement stands at the crossroads where science meets philosophy, challenging our understanding of reality itself. In this realm, every answer seems to lead to more questions. The journey is not about finding final answers, it's about embracing the beauty and complexity of a universe that continues to astound. Not all mysteries have answers, but we keep searching. Subscribe to join the hunt.